You're going to have one project this week and it's going to be found in Desmos, and there is the code. Make sure you sign in with Google. That way it will save your work. Also, I'm only going to assign some pages from that Desmos project. So wait until this video is over and you'll know which pages you're going to complete and which ones you're not going to complete. Before we start on the Desmos project though, I just want to review what we learned last week about how the graph moves. So y equals x squared is in black, and to graph that, it's really simple. You just basically square all the x values. So 0 squared is 0. That's why it's at 0, 0. Think of the number 1. 1 squared is 1. The number 2, 2 squared is 4. That's why it hopped up there. The number 3, if I go over 3 on the x-axis, 3 squared is 9. That goes all the way up there. Same thing happens with negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So once you have that parabola made, you can use that to make your orange and your blue parabolas over here. If you have a plus 3 after the x squared, it moves it up 3. I can just go from each one of these black dots and just count up 3 and make a new orange dot and draw the parabola. Same with the minus 1. That's going to move the parabola down 1. Okay, let's review. This one's kind of tricky. If the number is in the parentheses, with the x, it moves opposite of what you'd think. So if it's a minus 1, it moves right 1. And if it's a plus 3, it moves left 3. And you guys can see how I have my black parabola, and I moved the orange one right 1, and I moved the blue one left 3. Okay, let's remember what happens when we put a number in front of x squared. It's taking all the x squared values and it's multiplying them by 2. So instead of going over 1 up 1, you multiply that by 2. You go over 1 up 2. Instead of going over 2 up 4, you go over 2 up 8. And then that is why it makes it a skinnier graph, because it's growing faster. If you multiply by a negative in front of the x squared, and this is a negative 0.5, it takes all these black dots and it multiplies them by negative 0.5. So 1 times negative 0.5 is negative 0.5. 4 times negative 0.5 is negative 2. So basically you take all these black dots and you multiply them by negative 0.5, and that makes it a wider graph, which is upside down. Okay, let's talk about putting all of that together. So if you have an equation like this blue equation, let's break it down. The parentheses minus 1 means right 1. The minus 3 after the parentheses moves it down 3. That's called your vertex. You know your vertex is at 1, negative 3. This 2 in front is what makes it extra skinny, just like what we did on the problem we just talked about. So the first thing you want to start with is your vertex is over 1 to the right and down 3. And then you can kind of apply what we did here on this one, where this blue equation, this is a 2x squared. You go over 1 up 2, over 2 up 8. That's how I drew this parabola. So once I had my starting point, over 1 up 2, over 2 up 8, and you can reverse it to the left. This orange equation, a plus 2 in the parentheses moves it left 2, and then this plus 1 moves it up 1. That's your vertex. It's negative 2, 1. So negative 2, 1, that's the top of my parabola, and then I'm going to apply that negative 0.5, just like we did on the problem before this. Okay, and then just to kind of reiterate, the vertex is this bottom point, or it's the highest point if your parabola is upside down. So now let's start looking at the Desmos project. Again, here is what you go to, student.desmos.com. Make sure you sign in with Google. Here's the code, 9NVTNV. And these are the only pages we're going to do. We're going to skip the other pages. You're going to do pages 1 through 6, 8, 14, and 15. It will automatically go where I can grade you. You do not have to submit in Schoology. That's kind of different. As long as you're signing in with Google, I'm going to be able to see right in Desmos the pages you have complete. Okay, let's go through these pages step by step. So page 1, it shows page 1 at the top there. It also shows right here, this page 1 of 15. And basically, it's just a welcome. You don't have to do anything on page 1. I'm going to hit next. Page 2, they tell you what to type in. Try typing in y equals x squared. I'm going to show you how I do that on my keypad. Y equals, and then to do x squared, here's what I do. X, and then if you hit this caret, that shift was 6, that makes it up as an exponent and then the squared. And look what happens. The parabola shows up. That's all you have to do, and then hit submit. That's all you have to do for challenge 1. That one's easy. Okay, page 3, they do one graph for you, and this is like what we just talked about in our notes. What you're going to do is you're going to type in an equation for blue, green, and orange. So, oh, yep, there we go, and purple. So let's do the purple one together. It moved left 4. Do you guys remember when it moves left, it's in parentheses? So you have to type parentheses on your equation. Oops, I forgot my y. Y equals parentheses. Then do we want to do x plus 4 or x minus 4 to move it left? I'm going to try x plus 4, close my parentheses, and then you have to hit squared. I'm struggling. Okay. And then if you might need to scroll down a little bit, you do check my work and the parabola will show up. And look, we're correct. So you are still going to need to do the blue, green, and orange equations. So that's page 3. Page 4, you just pick. You have to read it and you pick if Eric or Jenny are correct. Page 5, this is like, this question tells you they want the vertex always to be at 0, 0. And they want you to find all the extra equations. So what I think is probably the most difficult one is the purple. It's upside down and it's really wide. Okay, the good news is it doesn't move left or right or up or down. So to make it upside down, hopefully you remember it's negative. And to make it wide, I'm going to try 0.25. I have no idea until I try it if this is going to work. So 0.25x squared. And I'm not going to know if I'm right until I check my work. And look, I'm really close, but does my graph need to be wider or does it need to be more narrow? And hopefully you're thinking it needs to be wider, meaning this 0.25 needs to become a smaller decimal. So I'm going to get rid of the 5 and just do 0.2 and check my work. And I'm getting really, really close. I still need to make the number a little bit closer to 0. So I'm going to try 0.19, check my work. And look, I'm going to call that good enough. So as long as you guys get close to those dots, you will be counted as right. So you need to come up with the other equations. This is one of the more time-consuming pages. That's page 5. Page 6, they give you the vertex, and they give you 2 other points. I know you can't see it right now. I need to scroll up. So if we know the vertex moves right 4 and down 2. So we just had this on that worksheet I showed you guys. If I want it to move right 4, we're going to do in parentheses x minus 4, right? We're going to close the parentheses and square it, and then we're going to have to move it down 2, which is minus 2. And then you just go to check my work, and if you hit all the dots, you're good. Well, I did not hit all the dots. I need to make it wider. So what you're going to do is go right here in front of that parenthesis and try typing in a decimal, like try 0.5 or 0.8, and then keep checking your work until it hits all 3 dots. That is page 6. The next page, you're going to skip 7 because we've not learned about that yet, and we're going to do page 8. Page 8, some are upside down, some are right side up. Let's go ahead and do the purple one together. It moves right 6 and down 1. The vertex is right 6 and down 1. So I feel like you guys should be getting the hang of this. So to move it right 6, think of what we're going to do in parentheses. To move right 6, it's x minus 6. Close your parentheses and square that. And then to move down 1, we're going to type in a minus 1. Always check your answer. Make sure you check your work when you're done. So that one's done for you. So you're going to have to do the orange and the green and the blue and the red. And that's page 8. The last 2 pages we're going to do are pages 14 and 15. You can skip all the rest. We're only going to grade myself and Mr. Couples for his class. We're only going to grade those problems. This one wants to know which equation is going to produce this graph. So again, you're just going to type in an equation and then push submit. And notice that your vertex is right 1 and it's up 9. See how that's an 8? So this point right here, it's right 1 and up 9 and it's upside down. So you should be able to do this, okay? And then finally, the very last one, you're going to draw your own graph. And the way you do this is you just click on where you think the vertex is. So this is telling me right 2 and down 4. I need to scroll down a little bit. So my vertex is right 2 and down 4. So it's right here. And then kind of think, all right, what does the rest of the equation have to do with it? So wherever you put your other dots, I would like you guys to show at least 5 dots. So I've given you guys the vertex. That's one of the dots. And then you need to put a total of 5 dots. So 4 more dots on this question. And then if you want to try your best to connect the dots, it's kind of hard. But as long as you have your 5 dots here, like this is your vertex, and then you get your 2 more on this side and 2 more on this side. And honestly, you guys could go to desmos.com, just regular graphing calculator to help you. So again, there's the equation, and I want to see 5 dots. And then when you're done, again, I'll be able to grade it from Desmos. Just make sure you do those problems. Again, it's pages 1 through 6, 8, 14, and 15. Make sure you sign in with Google so if you leave and come back, it remembers you. Okay? Good luck. Email me if you have questions.